Okay, in this video I'm going to continue on with exercise 5b of the book Fundamental Applied Mathematics. We're on page number 131 and the question is 9. It reads, two particles of 5 and 4 kilos respectively are connected by a light inextensible string passed over a smooth, light, fixed pulley. The particles are released from rest. Calculate their acceleration. So once again, please look at my video on the massless string. Please look at my massless rope, Look at my video on Newton's third law and my video introducing pulleys, the vectors used for pulleys and ropes. Alright, so let's go straight into this because I'm assuming you know all that at this stage. So this is going to be, by the way, please note my gravity vector and my unit vectors. Negative 4g j hat here. This is going to be negative 5g j hat. So for every action there's an equal and opposite reaction, of course, but in this case they're not actually hanging on the ground, so we don't get a normal force. So look at the tensional forces. We have one this way and one this way. They're on the same rope, so I'm just going to call it T. Now notice please, these are not Newton's third law pairs or action reactions. These are actually only due to the fact that the rope is massless. So let's apply Newton's second law. Newton's second law said that the sum of the forces on an object is equal to the mass of the object times its acceleration. So that's a pretty straightforward formula, or its application is anyway. So let's go for object number with the 5 kilos. So the sum of the forces is going to be Tj hat minus 5g j hat is equal to, now what direction are we going to give our acceleration? It actually doesn't matter, but I'm going to call it this way. So this is going to be negative a j hat, and this is going to be positive a j hat. Alright, and that's going to be equal to negative 5a j hat. Going to call that equation 1, and equation 2 would be about the 4 kilo mass. So we're going to get that Tj hat minus 4g j hat is equal to 4a j hat. Equation 2. Alright, so now what we need to do is, just to finish off this, we're asked to find the common acceleration. So what we need to do is get the tensional force in terms of G and A. So I'm going to use equation number 1 first of all, and I'm going to find that T is equal to 5G minus 5A. Now I know we still have the same directions, but at this stage, because all those directions are the same, as in we have only J here, you could essentially cancel your J's and you're going to be left with this. So I'm going to call this equation 3. So if I put equation 3 into equation number 2, you're going to get the following. You're going to get that 5g minus 5a minus 4g is equal to 4a. So you're going to get 9a over here is equal to g over here. So a is equal to g over 9 meters per second squared. So I'm just going to check that to the back of the book. So 5b question 9. G over 9 is correct. I'm just going to note the other answers while I'm at it as well. So 40g over 9 and 2g over 81. Alright, so that was pretty quick and pretty straightforward. So next part of the question asks us to find the tension in the string. Alright, so we know the acceleration is equal to g over 9. So getting the tensional force should be pretty straightforward. So I'm going to use equation 3 straight out. So we know that T is equal to 5 times 9.81 minus 5 times 9.81 over 9. Alright, so that's just a job for our calculator. So we have 5 times 9.81. Take away from that 5 times 9.81 divided by 9. Gives an answer of 46.3. The other way around, T is equal to 43.6. Now just see if this is the same as I got. Yeah, that's the same answer there, so that's correct. So we have the tensional force and we have the acceleration. The last part of the question asks us, if after 2 seconds the larger mass is caught and held, how much farther will the lighter mass rise? How much farther will the lighter mass rise? Okay, so let's just go back up to our diagram. What happens if this system is released? Well, then it'll rotate, well, not rotate, it'll kind of move in an anti-clockwise direction, okay? So the 4 kilo mass will go up, the 5 kilo mass will go down. So I'm just going to get rid of all the little forces we no longer need. Like so. Alright? Now, what it's saying is, if, say, where my finger is, we catch the 5 kilo mass. Alright? What will happen? The 4 kilo mass. Now, the 5 kilo mass will have been stopped, so it won't move any further. However, the 4 kilo mass will still be moving in an upward direction. Okay, now it's the force, the tensile force will be gone because we will have held the 5 kilo mass, but it will still be moving in an upward direction at a certain velocity. So we just need to find out how far it will go. So how we do this is as follows. We go back to our chapter 2 where we had accelerated linear motion, and in that chapter we saw our UVAST. So I'm going to look at the 5 kilo mass first, and we know the initial velocity is 0, the final velocity is unknown, and the acceleration is g over 9. Alright, we're asked what happens after 2 seconds. So we need to find the velocity and the distance after 2 seconds. So v is equal to u plus at, so it's equal to 0 plus g over 9 times 2. So it's 2g over 9, we'll say. Alright, that's pretty straightforward. And if you want to get the distance, we're going to use ut plus a half at squared. So s is equal to ut plus half g over 9 t squared, which is 4. So this goes in here, so 2g over 9 as well. Is that right? Something missing there. ut plus half a t squared should be v is equal to u plus a times t. Oh yeah, that's correct. Yeah, that's correct. Yeah, so 2g over 9 as well. Sorry, I was just getting a bit confused there myself. Alright, so that's for the 5 kilo mass. Now obviously when the 4 kilo mass is moving with it, the 4 kilo mass also has that same velocity. Alright, but we're asked what happens after it's been released. So its initial velocity is going to be 2g over 9, and we want it to come to rest. And the acceleration is going to be or the deceleration is going to be gravity. Okay, the gravity is decelerating it, and we want to find the distance. How much further will it move? So I'm going to get rid of the information for our 5 kilo mass. So s is equal to ut plus a half at squared. S is equal to, oh, we can't use that. Actually, we're going to have to use v squared is equal to u squared plus 2as. So we're going to get 0 squared is equal to 2g over 9 to be squared minus 2g times s. So s is equal to minus 2g over 9 to be squared over 2g. Alright, so this is once again a job for the calculator. So you have 2 multiplied by 9.81 divided by 9. We need to square that, divided by 2 divided by 9.81. Get an answer of 0.24. Alright, so just going to check that. No, I've made a mistake somewhere. Have I made a mistake somewhere? 2g over 81 actually. Yeah, 0.24. Sorry, I know I started getting confused there towards the end myself. But yeah, but that answer is correct. So sorry about there getting confused. But that, like I said, that is the correct answer. So thanks for watching. Please pass it on to your friends and subscribe to my channel.